property is a mathematical term for an identity or a true statement which can simplify a problem. For example, one of the exponent properties is a to the x times a to the y is equal to a to the x plus y. In this video, we're going to go over some derivative properties that will help simplify many of the problems you'll come across. The first derivative property we are going to cover is called the constant rule, which states that the derivative of any constant is 0. This makes sense because if we graph a constant function, such as f of x equals 3, we get a horizontal line. Because the line is horizontal, the slope at all points is 0. This is true no matter what point we pick, whether large or small, positive or negative. As long as we're just talking about a constant, the derivative is 0. The next property to consider is that we can factor out constants from derivatives. For example, we already know that the derivative of 3x squared is 6x because the power rule tells us to multiply by the starting exponent and then reduce the power by 1. Another way to think of this, though, is that we can pull that 3 out to the front of the derivative, take the derivative of x squared by itself, and simplify to get the same result. Of course, in this example, it's faster just to multiply 3 by 2 and reduce the power without the intermediate factoring step. But with trickier derivatives, like the derivative of 5x cubed over 3, this property can be helpful. To take this derivative, notice that we can factor out the 5 from the top and 3 from the bottom as 5 over 3. Then we can handle x cubed by itself. The derivative of x cubed is 3x squared, so we will write that now. From here, the 3's cancel and we are left with 5x squared. If you see a derivative problem with a coefficient, even a fractional one, you can use this factoring property to simplify the problem. The third and final derivative property we are going to cover in this video is the sum and difference rule. You will likely come across many derivative problems that involve functions with multiple terms. For example, you may be asked to find the derivative of f of x equals x squared plus 4x minus 5. There's nothing to fear with such problems though, because these derivatives can be handled one term at a time. The derivative of the first term x squared is 2x. The second term's derivative is 4, and the third term's derivative is 0 because it is simply a constant. So f prime of x is the sum of each term's derivatives, which gives us f prime of x equals 2x plus 4. The formal way of expressing the sum and difference rule is that the derivative of many terms is equal to the sum, or difference if the terms are subtracted, of each term's derivative. Let's quickly review what we've discussed in this video. First, the constant rule tells us that the derivative of any constant is always 0. Second, we learned that some derivatives can be made easier by factoring in a constant and handling the remaining function on its own. Finally, the sum and difference rule states that the derivative of a function with many terms is simply the sum or difference of the individual terms' derivatives. I hope this video was helpful. Thanks for watching and happy studying!